Here's my solution to problem 13.4 as listed in the lecture PowerPoint. It asks us to consider this figure down here, which I've drawn on the page, so I will show that in a minute. 2 points A and B are a distance, or an initial distance of 32 centimeters from each other, and the tensile force being applied is 980 newtons. The tensile strain is 0.06, and the tensile stress is 2.2 megapascals. So it asks us to determine the radius r of the rod after the force is applied and the total elongation delta L after the application of the force. So down here, we have the figure drawn out. We have the forces here and here, places A and B, and the initial length. So we know the initial length is 32 centimeters, force is 980 newtons, strain is 0.06, and stress is 2.2 megapascals. I have listed here what we need to find, and so here's the solution. So to find the radius, we know that stress is equal to force over area. So we can say force over pi r squared because that's the cross-sectional area of a cylinder. So we have that 2.2 times 10 to the 6 pascals, which is from here 2.2 megapascals, is equal to 980 newtons, which is our given force, over pi r squared. Rearranging to solve for r, we have r is equal to this equation, and then r squared is equal to this, and then r squared is equal to 1.418 times 10 to the 4th. So solving for that, r is equal to 0.09 or 0.0119 meters. And then I converted it back to centimeters, so it's 1.19 centimeters after application of the force. Now, we know that to find the elongation delta L, we know that strain is equal to delta L over initial L. So 0.06 is equal to delta L over 32 centimeters. So we know that delta L is 0.06 times 32, which gives us 1.92 centimeters for the change in elongation.